Unit 2, Solving Quadratics. I'm hoping this review is the most memorable / easiest for you because we've been working with solving quadratics for so long. Also, this is like the most important unit of the year. Like if you go to Sec 3 and you don't know how to solve quadratics, then I look bad and I just can't have that. So we got to hit it again. Please enjoy this joke of the day. Pause it if you want to read it more because we're just going to carry on. So first, let's talk about factoring. The thing about factoring, remember, all we're doing is we're basically undistributing something. So like I'm taking a trinomial and I'm going to see what two binomials did it come through from distribution. We have 3 different kinds of factoring, or like 3 different cases. There's when a equals 1, remember our little standard form, ax squared plus bx plus c? Yeah. We have a does not equal 1, and then we have a difference of squares. Before I even touch on that, I'm going to ask you, rhetorically, because I can't hear your answer, what is the first thing you always look for when you factor? I hope you responded GCF like Dora the Explorer, because that is what I needed you to say. GCF meaning greatest common factor. You probably noticed I wrote that in red. Glad you noticed your colors. Okay, we're going to start with some a equals 1 examples. So let's say right off the bat, let's just go x squared minus 7x plus 10. I'm going to lowball you first. Okay, do I see a GCF? GCF would mean that I would have a coefficient or a variable in common for all 3 of those terms. I do not, therefore, no GCF. So we're going to multiply the first term and the last term. So 10x squared. All right, what 2 numbers multiply to 10x squared but add to negative 7? Well, our only possible factors of 10 are 1 and 10 and 2 and 5. And so, oh, okay, I see. If I have a negative 2 and a negative 5, that adds to negative 7, and that multiplies to positive 10. And because we had a equals 1, the reason we care about that is because we can use a shortcut, meaning I can just go x and then the minus 2, and I have x minus 5. We got those from right here, and we are done factoring. If you're ever unsure about, oh, did I factor that correctly? Hey, remember how factoring was just undistributing, which means if you redistribute it, you would get the same thing. Oh, look at that. That's smart. Okay. Next example. Let's do 2x squared minus 24x plus 54. Okay. First thing, is there a GCF? Why, yes. Yes, there is. I can look at all 3 of these guys and see that those are all divisible by 2. So I factor out a 2 and get x squared minus 12x plus 27. And then we are going to factor what's on the inside. That GCF out front, sometimes it could mean greatest common factor. It could also mean greatest common friend, because a true friend stays with you to the very end, just like this GCF will do for you. Isn't that nice? Okay, 27x squared. Let's see. 3 and 9. Oh, look at that. I can make both of those negative. And now, my a value. I'm only focusing on factoring what's inside the parentheses, so because this x squared is by itself in here, as in that coefficient is 1, we can still use the shortcut. That 2 of GCF stays out front, and then I got x minus 3 and x minus 9. One last refresher for you. GCFs don't always just look like coefficients, because I could have 4x cubed minus 20x squared minus 144x. Oh, hey, wait a minute. Sure, all of those are divisible by 4, but all of them also have an x on them, so we could also take out x. We get x squared minus 5x. What is 144 divided by 4? 36? Okay, what multiplies to negative 36 and adds to negative 5? Let's see, 3 and 12, 4 and 9. Hey, there it is. Just strap a negative on that 9. GCF stays out front, and then I got x plus 4 and x minus 9. Please also remember if the first term is negative, factor out negative 1 as the GCF. Negatives totes count. Okay, here's just another example that I see a lot of you guys get confused on. 2 terms. Well, crap. Well, what's the first thing we look for? GCF. Do we have a GCF? Okay, GCF is the variable n, 7n minus 5. Well, there's nothing else to factor on the inside because really factoring happens with quadratics. That's a linear binomial inside that parentheses. That means we're done. And that's great. That means it's less work for us. Okay, let's see if we have... Let's go 3n squared minus 31n plus 70. All right, I see no GCF. Ah, crap, a does not equal 1, so we just gotta go for it. 210 n squared. Okay, what's gonna multiply to 210? Well, we know 3 and 70, 21 and 10. Oh, hey, if I make both of those negative, we've got it in the middle. Now, a does not equal 1. Remember that a value from standard form? 3 is not the same as 1. Fun fact. That means we cannot use the shortcut. So what's going to happen is, notice because this is an n squared that we multiply to, that's negative 21n and a negative 10n that we would have to multiply by to get the negative 31. So I'm going to rewrite my original problem, but instead of negative 31n, I'm going to replace it with what I found right here. So I'm going to go negative 21n minus 10n and plus 70. And now what's going to happen, we're splitting that thing in half. This is called factoring by grouping because we're splitting our problem into groups. So we are going to look at the GCF of the left side, which is 3 and an n. So I get n minus 7. On the right side, I would say 10, but remember what I just wrote in red up here about the first term being negative? Oh, hey, look, there's a negative in front of that 10, so I'm going to pull out negative 10, and I get n minus 7. If these two are the same, that means you did it correctly. If they're not the same, go back and check your work. Because now what's going to happen is these ones out front come and make their own parentheses. 3n minus 10. There we go, okay. Now my Apple Pencil died again. So it's 3n minus 10 times n minus 7. I'm going to pause.